first one is the core platform. The core platform is somewhere in the cloud, and it's where the microservice will be hosted and will be run at runtime. In fact, it's a media server which allows to create vocal services. It's a web server. It's MySQL hosting, and it's access to web API. So on this core platform, a developer can connect and request an environment creation, and then he will choose what feature, what facility he wants to have for his project. So it's the core part of Emerginov, and then it's connected to gateways, connected to local telecommunication network in the different countries who want to, let's say, play with Emerginov. Those gateways allow connection to voice network, PSTN, to GSM network in particular, allow to send and receive SMS, and of course it's connected to the internet. So this is the base of Emerginov. Emerginov by itself is not directly used by an end user. Emerginov is a tool for developers to allow them to quickly create and prototype microservices. And it was the case for Sensonet, which was at the beginning a simple microservices built over Emerginov. The second thing that I would like to present you before speaking about Sensonet itself is Arduino. In fact, Sensonet, I have to say this first, of course. Sensonet is a solution which allows to create and to prototype any kind of connected object sensors network. So to build the part of objects, the physical part, the hardware, we are based on the Arduino. The Arduino is in the family of open hardware. We're going to speak about open hardware just a little bit later. But what is an Arduino? An Arduino is a simple card like that, and on this card you can find a programmable GPIO microcontroller. In fact, it's an electronic component where you are going to build an algorithm, not by soldering component, but by programming. It's not so new, in fact. It exists in the electronic world for many years now. But the main idea of Arduino, there's many, but one which was very nice is, in fact, this microcontroller is on a board where you can find an USB serial interface which allow to connect this board to your computer and which allow to program and to flash your code on the microcontroller. It's embed, for example, a power supply to connect this board not to a computer but on a battery with solar panel, for example, to allow the runtime. The same card will be used for programmation and for runtime, and it's what is very, very nice. In the past, when you have to program such GPIO microcontroller, you have to connect it first to your programming environment, flash the code, then pick up the chip itself, go to the PCB that you have built by yourself, and then plug this microcontroller in a specific slot and so on. With the Arduino, you have an all-in-one solution. So on this board you can find here some pin connector, which are in fact electrical connection to the different connectors of the chip itself, which allow you to interact with the real world. The microcontroller, the GPIO microcontroller, allow you to read different status for those connectors, high, low, or analogic. We are speaking about electronics, so when I say analogic, for sure it's digital value, but it's no more false or true, it's a larger range. So this is the base of our object. The fact is that all the design of those cards is open source. It's what we call open hardware. The open hardware doesn't mean that the physical equipment is for free on the internet. The only thing that is for free on the internet is the design of the card. You can download it and build your own card, and it's what some industrial companies or commercial companies do, for example. So this is the base of our object. It's just the main board, let's say, of objects. So the The key point with Arduino is that you start with your main board. You can plug on the connectors some extensions, which is called in the Arduino world Shield, which are extensions which give you different facilities, different possibilities, which extend the possibilities of your electronic block. For example, on this picture, we can see Wi-Fi connector. So by plugging this shield on my main board, I have now on the hardware aspect an equipment which is able to have a kind of algorithm running and which is able to connect over Wi-Fi. The other thing is that you can plug through those connectors, you can plug sensors, device, motors, controller, water level sensor, different things like that. So the first step with Arduino is to play with the hardware, to plug all the required elements. Then with a little bit of C++, you can create the glue for all those components, and the result is a prototype for an object. The key point is that Arduino, it's not the only platform which is able to do that. This one is nice because it's open hardware. The fact is, it's allow IT people to touch the electronic world, the hardware world. It's my case. At the beginning, I'm not an hardware engineer. I'm a software engineer. But with Arduino, I can play with hardware, and that's nice. So I spoke about Emerginov, I spoke about Arduinos, so now let's speak about Sensonet itself. So Sensonet is in fact an enabler. It's an enabler which allows you to create and to prototype any kind of connected object. It can be, of course, sensors network. At the beginning it was only for sensors, so the name is coming from here. But it gives you the possibility to create objects which are more than sensor. You can give orders to your object, and they can interact with the real world. The idea is to provide, in fact, a solution which allows to build this quickly and for cheap, in fact. So the main thing is here is the core component, or let's say the network component. It's kind of backbone for connected object. It's the part which is located on the Emerginov core platform, with here in the south connection a set of different RESTful web services which allow developers, web developers, for example, or mobile developers to interact with this platform and discover all the existing networks, and discovering on those networks the connected objects which are plugged, to see what is the global topology, to have information about values coming from the object deployed on the field, to send orders to those objects. And here on the north interface of Sensonet, we have in the V1 of Sensonet the possibility to communicate between objects, I mean Arduinos on the field, and the backbone through an SMS send and receive protocol. So the great thing with SMS that it's very easy to deploy. You don't need a huge infrastructure component. I mean, if you want Ethernet or if you want Wi-Fi, you probably need a router. You will probably need an EDSL line. You will need power supply, things like that. With GSM, it's easy. You just need a SIM card, a power supply, which can be a simple battery, and then you are connected. Everywhere where you have a network coverage, you can send and receive SMS. It's not necessarily the case with 3G or Edge or 4G. With SMS, it doesn't require a huge infrastructure. Of course, SMS on the paper does not ensure delivery of messages, but in fact it's a relatively reliable protocol. So it's a very interesting base to deploy objects let's say all over the world. So we have a discussion between objects and the core network using SMS, and then you can interact with all the topology, you can discover all the topology, you can interact with objects through regular REST web services. So it was the V1 was SMS. For the V2, which is coming in the next few weeks, we extend the possibility to have an HTTP connection between object and the core network. So one of the major issues with SMS is no guarantee of message delivering and a very long latency time. I mean, if I send an order to my object, I have to wait that the SMS is sent by the core platform to the object, then wait to have the GSM network to deliver the message, and then on my object I can do something according to this message. With this message, with HTTP, it's more efficient, in fact. On the other side, with HTTP, you probably require, like I was telling to you, hotspots for Wi-Fi or a router for connecting Ethernet and so on. So it's requiring heaviest level of infrastructure. So the idea is here to open all those API to web developers, which are not experts of SMS protocol, which are not experts of object management, but to give them the possibility to interact with the technology where they are master at. I mean, web. On object side, the idea is to provide them a high-level library on Arduino. It's like I was telling you, it's C++, which will manage all this communication with the backbone. The fact is that on Arduino it's hardware, so it's very often very low-level libraries. I mean, for example, if you want to send an SMS, you have to read and to send byte per byte to a modem at instruction. It's very painful. The idea of Sensonet is to provide here a high-level library where all this communication is completely managed by the library and where the developer will only focus on his main code. The idea is to completely hide this protocol to the developer to make it easy. So here, for example, we have two different views of exactly the same thing. Here, the web services providing the network architecture, the network topology, and here a regular web application using those services to provide a view of deployed object on a particular network. And here, it's an Android application. We will have a demo of this application just later, which is using, in fact, exactly the same web services through the internet. So, what is our target? Our target for Sensonet is makers. The idea is to build quickly prototypes, because we think that the best way to develop an idea is not only to create slide, it's also to create prototype, because when things are running in real life, it's more easy, it's more simple to see where are the limitations, where are the good ideas, where are the bad ideas. And it's typically the scope of Emerginov, and it's typically the scope of Sensonet. So our target is M2M developer, it's Fab Lab. The idea is to build something like Telefonica done with the Arduino community, and to author all those facilities to give access to hardware to IT engineers and IT developers. The fact is that it's more and more IT focus in high-tech. So the idea is really to bring them to the real world. The fact is, on the internet, very, very, very often, it's only virtual world. Here, the idea, by providing hardware and controlling hardware, is to connect internet in the real world, not only on virtual one. So our scope is also small entrepreneurs, which are able to create small services and small objects, but who are not ready to invest a huge amount of money in very huge and industrial solutions, which are very often very expensive. Our scope, like I was telling you, is prototyping, is proof of concept, and Sensonet was born in the Emerginov context, which is really focused on Africa. Emerginov was built for African market to develop co-innovation, and it's typically why, for example, we are using SMS, because in Africa, network connectivity is not always, not everywhere with 3G like it's in America or in Europe, but GSM and SMS is everywhere, so it's a very nice way to connect objects all over Africa. So we are going to come back on what I already said, so it's kind of resume. The idea of Sensonet is to have an enabler. It's not a solution, let's say, ready to use for end user. It's really our target is developer. It's to provide them an M2M IoT. It's depending on what they want to do. We give them the possibility. It's an M2M and IoT enabler. The second point is this adaptable connectivity depending on your requirements. I mean, if you want a huge reactivity and if you want to be sure that you will not lose some messages, then use the HTTP version. But let's say the dark side of the force is that you will need power, you will need infrastructure. If your purpose is to be able to deploy your object all over a country, in particular in part of the country where there's not huge infrastructure, where there's quite nothing, use SMS. The other point is hardware for IT developers, and I think it's very, very important. One of the best added value of Sensonet is to provide through all those API, REST API, a unified management to connect all those objects. I mean, I'm a web developer, for example. I subscribe to a particular event on the Sensonet backbone. I'm telling you that it's a SOA REST services set of API. Sometimes it's synchronous API. I mean, I send my request, typically an HTTP GET, to know all the list of objects deployed on a particular network. Is the more obvious view of an API, but it's not the only way. They're the only one. There's also a publish and subscribe mechanism, allowing a web application, for example, subscribing to Sensonet, to receive events on a particular web services implemented by this web application, to be notified that something has changed on the network. The idea is that this application will focus on the core business of itself. I mean, for example, we will see an example later. For example, it was solar panel monitoring, and will not focus on object management. Sensonet will do that. So the idea is, with this unified management, you will focus on your core business and don't have to know if it's HTTP or it's SMS or it's something else in the future. I don't know. You are just using the same interface and the same way of managing whatever the connectivity on the field with the hardware is. So, like I was telling you, it's not directly used for a business, but it's an asset which allows you to create and to build your solution, and it's something I think on this point of view very, very, very interesting. So let's switch to the next slide. So I was speaking about different examples. The first one is this one, is the solar panels failure detection in school in Africa. In fact, it's in Senegal. The Ministry of Education deployed some solar panel to produce electricity in school. The idea here is that sometime it's falling down and nothing happened. The idea is to deploy a monitoring system which can alert different technicians in charge of repairing those solar panels. So we build a single object which is only detecting if the solar panel is producing current electricity or not. And when it's not producing electricity, I mean it's fall down, then it sends a notification to Sensonet. Then we have an application which subscribes to the notification coming from Sensonet, and this application takes in charge the interpretation, the meaning of this event. It will define, for example, that this particular panel is connected in this particular school, and for this school, this is this particular technician which is in charge of repairing solar panel, and then this application will contact this technician by mail, by SMS, by phone call, by anything else. So Sensonet was used for this monitoring system. Another experimental is an experimental bus tracking in a relatively small city that some people knows here on the bridge, who wants to create value-added service about buses. But the fact is that it's too early in the process to invest in a huge industrial solution to buy to major actors on the market a solution for bus tracking. Here the idea was to build a very simple object to put it in a bus. In fact, it's an Arduino plus the GSM connector plus a GPS tracker. Then this object will send regularly its location in the city. Again, on the Emerginov platform, an application subscribes to events coming from this object and can build added value services to notify user that the bus is coming and so on. So it's a different use case, but it's exactly the same solution to build object and to manage object on the field. The other one is typically a sensor for collecting environmental parameters and to have all those values consolidated in a database on the internet. Another one which is so useless is the connected Christmas garland. It's probably the first connected Christmas garland over the world. The idea was very simple. It's just to have this Christmas garland in your grandma tree and then to send a simple SMS to change the light, the color of the light on this Christmas tree, or to have a web application where you can connect and choose again the color and the speed of blinking of this garland. And in fact, the main interest here is not the garland by itself, but it's to see that with the same object, you can have an interaction with simply sending SMS to this object, or from a web service from the internet, where you can send from a web application as well instruction to your object. In the same kind of idea, we have a contactless connected switch. Typically, the use case is if I push a button here in Rennes, it will switch on a light or an engine, let's say a power supply engine. The fact is, nothing more to do for the developer. Instantly, a message will be sent to Sensonet core network, and then the fact that the engine is running is known all over the internet. It means that, for example, in Dakar, Senegal, somebody can connect this web service and know that the engine is running. The fact is, by sending an SMS to this switch, I can switch off the engine. So from Dakar, with a single SMS, you can send an SMS and stop the engine. Or again, by using a web service, in a web application, in an Android application, for example. In Paris, you can again switch on or switch off the engine. And the last example is the beehive monitoring system from a Fab Lab in Lannion, where the idea is to detect when bees are leaving the hive. So the idea again is to have an Arduino on the field, which is able to determine the weight of the beehive and to send this information to a core business application which interprets all this information about weight of the hive, and this application should be able to notify people responsible for beehive that something is happening.